All right, Algebra 2, we're going to go ahead and start Unit 3.5. We're going to look at another method of solving quadratic equations, and this is using what are called square roots. So we're using the square root method. So the first method was using factoring, and so this is the second method, and then there'll be a third method also that we'll get into. All right, so the general form or standard form of a quadratic equation, ax squared plus bx plus c equals 0. All right. And then because the x squared term, that means there's always two solutions. So always look for that. So if you have one solution, there could be an error in your math. All right, so if we have the equation x squared equals 9, we're trying to find a number that we can plug in for x and square it, and it equals 9. And so positive 3 would work, because 3 squared is 9, but also negative 3 works, because negative 3 times negative 3 is also positive 9. All right, so you can see for x squared equals 9, that equation, we get two solutions, 3 and negative 3. All right, so here's our steps that we're going to use. And we kind of use these same steps a lot in different types of equations, and we've already seen these before, like with the absolute value equations. So we isolate the x squared term, and then what we're going to do is square root both sides. Now, because we're going to square root both sides, that's going to produce two answers, one positive and one negative. All right, so we're going to use that plus or minus symbol, and then we can simplify the radicals if we can, and then we'll continue to solve for x. All right, and so that's why you can see x squared equals 9. We get positive 3 and negative 3. All right, so let's go ahead and do number 1. All right, so the first thing we're going to do is isolate that x squared term. So we're going to add 25 over. All right, so we get x squared equals 25. Now we can square root both sides. All right, so the left side, when you square root a squared term, they cancel each other out because they're inverses of each other or opposites of each other. And so they cancel each other out, and you get x equals. Now we're going to put that plus or minus in front of the radical, 25. All right, and now we want to go ahead and simplify the radical if we can. Well, square root of 25 is exactly 5. So we get plus or minus 5. And you can use that plus or minus symbol. Sometimes you'll see they'll separate it as like negative 5 and positive 5. And that's okay too. You can separate it or use that plus or minus symbol. All right, so number 2, x squared plus 13 equals negative 3. All right, and so we're going to subtract that 13 over. Okay, again, we're trying to get that x squared term by itself. So we get x squared equals, that's going to be negative 16. All right, again, we'll square root both sides. So the left side is just x, the right side is plus or minus the square root of negative 16. And now we want to go ahead and simplify this radical if we can. Well, we know we have the negative that we can pull out, and so when you pull this negative out, it goes in between the plus or minus and the radical. All right, so we have I plus or minus I root 16. Now, root 16 can simplify down to 4. It's perfect. All right, and so we get plus or minus 4i. Okay. Again, if you wanted to separate it, that would be negative 4i and positive 4i. But again, you can just use that plus or minus symbol. That's fine. Just make sure you don't put the 4 in front of the plus or minus, so it's not 4 plus or minus I. So be careful with that. All right, so let's do 3. So you can see in all these problems, the quadratic equation, the general form here, has an x squared, an x, and then a constant term. All these problems really, they don't have they have the x squared term, but they don't have the bx. So there's no x to the first power in these equations, and this is what allows us to square root both sides. All right, so number 3, x squared minus 12 equals 8. All right, so let's go ahead and add 12 over. So x squared equals, what's that, 20? All right, and then we'll square root both sides. So we have x equals plus or minus radical 20. Now we can simplify this. It's at 4 times 5, 2 times 2. So there's a pair. So that 2 comes out. And so we have plus or minus 2. And then we have that 5 left over. And so radical 5. All right, again, make sure the plus or minus is coming first and then 2 root 5. All right, number 4. We're going to go ahead and subtract the 1 first. Don't divide by 3. Subtract 1. All right, so 3x squared equals negative 21. And we can divide by 3. All right, now we're going to go ahead and square root both sides. All right, so the left side is x equals plus or minus root negative 7. All right, we got that negative under there, so we're going to pull the negative out. So we get plus or minus I radical 7. And then 7 doesn't simplify any further, and so that's our final answer. All right, number 5. So we have this x plus 1 squared equals 36. So this is a binomial squared, and it is, so the x squared term is isolated. All right, and so what we can do is go ahead and just square root both sides. And so we get x plus 1 equals, again, plus or minus radical 36. All right, and then we're going to go ahead and subtract the 1 over. And so we get x equals, now you can't subtract 1 from 36. We're going to write it like this, negative 1 plus or minus radical 36. All right, now we can simplify the radical. So we get negative 1 plus or minus 6. And so if you remember, I said you could write this without the plus or minus. So this is the same thing. On this type of problem, you want to write it out separately because we can actually simplify each of these. We can combine like terms. So we have negative 1 plus 6, and that's just going to simplify to 5. And then we have negative 1 minus 6. That's negative 7. So here we get these two answers, and you have to write them out separately like this, 5 and negative 7. I mean, obviously you can, it doesn't matter if you write it like that. But you can't leave it as negative 1 plus or minus 6 because it does simplify. All right, number 6. Here, we're going to isolate the x minus 5 squared term, and so we're going to divide by 4. Right. Again, you can't distribute the 4n, and that's because of the square that's sitting there. It's almost like the absolute value. You're not allowed to distribute into the parentheses if there's a square there. All right, so we have x minus 5 equals, x minus 5 squared equals 5. All right, now we'll go ahead and square root both sides. X minus 5 equals plus or minus radical 5. I'm going to add 5 over. Okay, again, we want to put it in front of the plus or minus. All right, and then we would try to simplify radical 5. And radical 5 doesn't simplify. And so we can't combine like terms because 5 and radical 5 cannot be combined together. And so we could leave it just like this. All right. Again, if you wanted to separate it, and sometimes you'll see answers, maybe a multiple choice test, they separate the two. So just so you get familiar with separating it, okay, this means the same thing. All right, so instead of using that plus or minus symbol, 5 plus root 5 and 5 minus root 5, same thing. But you could write it either way. All right, number 7. Subtract 6 first. So x plus 2 squared equals 24. Okay, we'll square root. X plus 2 equals plus or minus radical 24. Subtract the 2. X equals negative 2 plus or minus root 24. Now we can simplify this radical. It's 4 and 6, 2 and 2, 2 and 3. So there's a pair of 2's. So a 2 is going to come out. And then the 2 and the 3 are not paired up, so we multiply those back together. Keep it inside the radical. All right, so we have negative 2 plus or minus, pulling the 2 out of the radical. And then the 2 times 3 gets left inside 6. Now, negative 2 plus or minus 2 root 6, you cannot combine those together, and that's because the negative 2 doesn't have a radical 6 next to it. So these are unlike terms. And so you can't combine them, so that's your final answer. All right, 8. Here we have a couple steps we got to do before we can square root. So we're going to subtract 3 first. It's 14. And then we'll divide by negative 2 next. It's negative 7. All right, and now we can square root both sides. So we get x minus 1 equals plus or minus radical negative 7. Add that 1 over. I'm going to pull that negative out of the radical, so it's I root 7. And then 7 doesn't simplify, and so we don't have like terms, meaning we can't simplify this any further than 1 plus or minus I root 7. All right, and then I think it's in the next lesson, we're going to end up with problems similar to these, and so we have to be able to simplify this. And this is going to kind of come back from, I think, complex fractions. This concept on the division part is going to kind of come in here. All right, so question A, we want to simplify 4 plus or minus 8 over 6. Now, because there's no radicals in this problem, we can actually do 4 plus 8 divided by 6, and then we can do 4 minus 8 divided by 6. All right, and so we can do order of operations, which means you have to add or subtract on top first and then divide by 6. So 4 plus 8, that's going to be 12 over 6, and that'll simplify down to 2. And then 4 minus 8 is negative 4 divided by 6, and we can simplify that fraction, so that's going to be negative 2/3. All right, so that's going to be what this simplifies down to, positive 2 and negative 2/3. All right, B, we have a radical in here, so we always want to try to simplify our radicals first, and radical 5 doesn't simplify. All right, so this is where the concept from division of complex numbers come in. Anytime you have 3 numbers here, okay, so you have that 6, the 2 on the outside of the radical, and then there's another number in the denominator, so you got 3 numbers there. If you can find a number that divides into all of them, you have to divide it. Okay, and so we can divide everything by 2. All right, so 5 has nothing to do with it. It's just the numbers on the outside. So you got to have 3 numbers. Okay, so we can divide them all by 2. So this is going to be 3 plus or minus. Now that 2 goes to a 1. If you want to put the 1 there, you can in front of the radical, but you don't have to. It's already assumed it's 1. And then that's all divided by 1. And because it's being divided by 1, you don't have to put it. You can, okay? So you can put the 1s in there by dividing by 2. But typically you would just write it like this. All right. And then C, here we can simplify the radical, all right? And so we want to simplify it. So we can pull the negative out. All right, so I have negative 9 plus or minus I root 9 over 3. And then radical 9 simplifies. So we have negative 9 plus or minus 3i over 3. All right, and just like with the radical, because we have 3 numbers here, if we can divide them all by a single number, you got to divide it. And here we can divide by 3. And so we want to divide each of those by 3. So negative 9 divided by 3 is negative 3. And then plus or minus 3 divided by 3 is 1i. So 1i. Okay, all over 3 divided by 3 is 1. And again, because we're dividing by 1, we don't have to put the 1. Negative 3 plus or minus I is fine. All right, and then this last one, number 10, given the equation in standard form, so this is a review problem, standard form, ax squared plus bx plus c, find the vertex. All right, so remember in standard form, to find the vertex, the first thing we're going to always use is x equals negative b over 2a. All right, and that's going to help us get the vertex, but we're actually using this answer to get the x-coordinate of the vertex. Okay, so it's the axis of symmetry number, but it's also the same as the x-coordinate of the vertex. All right, so here's our A, our B, and our C, and so we're just going to plug those into this formula. So it's negative 12 over 2 times 2. So that's positive 12 over 4, and that's 3. All right, so the x-coordinate of our vertex is positive 3. And it's also the axis of symmetry, x equals 3. So now to get the y-coordinate, we're going to plug 3 in for all the x's. So again, you could use your calculators for this if you want, that's fine. So again, just plug 3 in. 3 squared is 9 times 2 is 18. Negative 12 times 3 is negative 36 plus 5. 18 minus 36 is negative 18 plus 5 is negative 13. All right, so that's negative 13. So here's our vertex, 3, negative 13. Now, in question B, it says write the equation in vertex form. All right, so we want to change it from standard form into vertex form. Now, if we know the vertex, then this is what allows us to change the form into vertex form. Right? And so we have this A, the H, and the K. Well, the H and the K is our vertex. That's how you get the vertex. And then the A is really just the same A as in standard form, okay, which is positive 2. All right, so all we have to do is plug our 3 numbers in, A, H, and K, and into this formula, and we have the vertex form. So y equals A is 2 times x minus the H value, which is positive 3, squared, and then plus K, and so K is negative 13, so you can do plus negative 13 or just minus 13. All right, and so that's a vertex form. Again, in vertex form, to get the vertex, you take the opposite sign of that number, same sign as that number. And again, it's the same that we wrote, vertex 30, negative 13. Okay, so that's just review. All right, that's it.